Hey everyone, Mrs. Crowley here. So it looks like we're having a little bit of problems with this whole heat of solution stuff. Thought I might assist you. So what we've got going on is some data from one of the students. They provided me the heat of solution that they determined for sodium carbonate. And from their calculations, they received a value of negative 29.9 kilojoules per mole. Now, I want you to remember that when you were doing the calculation for the heat of solution for all of these compounds that we tested, you took into account the amount of heat that was absorbed from the calorimeter itself. So what this value here represents is the total amount of heat that was lost. Now, some of that heat will definitely be absorbed by your calorimeter, and we'll take a look at that in just a second. But why don't we start off by first figuring out exactly how much heat, grand total, would be lost when we add 10 grams of solute to a solution. So what I'm going to do is I'm going to take the 10 grams of solute, convert that to moles, which is what you see right here, and then multiply it by my value of delta H solution for sodium carbonate, which is right here. Let's figure out exactly how much heat, grand total, was lost. I get negative 2.82 kilojoules. Now remember, this represents the grand total amount of heat that was lost during the solution process of 10 grams of solute. So, some of that heat is going to be absorbed by the water, and some of it will be absorbed by your calorimeter. Why don't we figure out exactly how much of each you're going to get? Alright guys, so let's take a look at what we've got here. This piece right here represents how much heat is going to be absorbed by the water. Now I want you to pay special attention to the units here, okay? So this is the heat capacity of water. This is how much water we had in the reaction. And then what we would normally do is we would multiply that by a change in temperature, right? Because you see that unit right there, the degrees Celsius. Over here, this unit, this value, came from the student's data. This is actually the heat capacity of the student's calorimeter. Every time we get a change in degrees Celsius, we also have a certain amount of heat that is being absorbed. So if you look at the units, joules per degree Celsius, we see that every time a change in Celsius happens, we are going to have 44.2 joules being absorbed by the calorimeter itself. So this formula here may look a little bit familiar. The heat of the overall solution process. Some of the heat will be absorbed by the water, and some of the heat will be absorbed by the calorimeter itself. So I hope that you understand that we have to look at how much heat was absorbed by the water and how much heat was absorbed by the calorimeter at the same time. Alright, so I did a little simplification of the math here. I took those items in yellow and I multiplied them together, and I got this value right here. Notice that the grams went away in the heat capacity of water. The grams are gone. And now it's just joules per degree Celsius. And this value right here represents the heat capacity of the calorimeter again. Alright, further simplification will bring you down to 211.4 joules per degree Celsius. I just combined those two values, and you still see your delta T sitting outside there. So, multiply through, simplify, and you should be able to get a change in temperature of 13.3 degrees Celsius. Alright everyone, I hope this really helps, and then if you have any further questions, don't hesitate to email me again. Bye-bye guys.